All right, and welcome to the second part of the Spring Break 2018 hints, if you will, on your review packet for the AP exam. I hope, again, you are having a good time or that you had a great break. Today is Sunday, so we're about to be coming back tomorrow. Look forward to seeing you guys on Wednesday. Anyway, let's start taking a look at the first problem, the next problem in the set. This would be the seventh problem that you have. It would be the start of the second part of this packet. It is a calculator problem. The first two in this video will also be calculator problems, and then the last four will be non-calculator. So let's go to the first problem right now. In this one, we have a tank has a given height of 10 feet. Area of the horizontal cross sections of the tank in height are given by this function here. So you have to take a look at this one and remember that these values here are areas of the cross sections that we have. Okay. And it's measured in square feet. The function a is continuous and decreases as h increases. Select values of a of h are given in the table above. So the first thing I want you to do is use a left Riemann sum with the three subintervals indicated by the data in the table to approximate the volume of the tank. Remember here, okay? Remember what you're looking at, and keep in mind, you're looking at a left Riemann sum is an approximation for a definite integral. And remember that one of the things you have to deal with when you work with this is to just double check what happens with the units. The units here, when you deal with a definite integral, multiply the units. So you have feet and square feet. So when I multiply those together, I'll get the cubic feet. So that will be a volume. Okay, so just go through on this one. You're just doing a left-hand Riemann sum. And again, indicate those units of measure. In this next one here, does the approximation of A overestimate or underestimate the volume of the tank? Okay, now you got to go through things that you're going to have to keep in mind on this one. They tell you here, function A is continuous and decreases as h increases. Okay, so use that information. Think about what that means in terms of going through and determining if this is an overestimate or underestimate on this problem. Also, it might be helpful to just plot the points out. Okay, plot the points out. Take a look at what's happening if you're going to deal with a left-hand Riemann sum. Treat the h as x and then the a of h as your y values on that. For part C, the area in square feet of the horizontal cross sections at height h feet are modeled by the function f of h right here. So this is the area in square feet. Based on the model, find the volume of the tank, indicate units of measurement. Okay, so remember what's happening on this one. You're trying to find a volume. I want you to think back. When we talk about finding a volume, you are integrating an area. And here, they've given you an area. Okay, so you're going to have to set that up. This one right here, in terms of working with it, this is a calculator section for a reason. Okay, so don't try to integrate a function like this because number one, you're not going to, and number two, it is a waste of time. You have your calculator, go ahead and do that. Water is pumped, part D, water is pumped in the tank when the height of the water is 5 feet. The height is increasing at a rate of 0.26 foot per minute. Using the model from part C, find the rate at which the volume of water is changing with respect to time. When the height of the water is 5 feet, indicate units of measure. Okay, so find the rate that the volume of the water. Okay, remember the volume. You want to use this information there based on go through how we found that volume. Use that to kind of help yourself out in terms of making that determination on this one. Okay, because they want to know, find the rate at which the volume of the water. So they want you to find dV dt on that one. So keep that one in mind. And think about the key part there is what you did in part C with this model. Okay. Let's go ahead and move on to question 2. Question 2. When a certain grocery store opens, it has 50 pounds of bananas on a display table. Customers remove bananas from the display table at this rate right here. So this is a rate that the bananas are going to be taken from the display table. Okay? After the store has been open, then the next part where F of T is pounds per hour. Then the next part, after the store has been open for 3 hours, store employees add bananas at a rate modeled by this. And notice it's from 3 to 12, where this first one went 0 to 12. And again, G is measured in pounds per hour, and T is the number of hours after the store is open. So what you have here, you have two functions, both representing rates. The first one, the rate at which F of T is the rate at which bananas are being taken from the display. G of T is the rate at which bananas are being added to the display. Okay. Now, first up, how many pounds of bananas are removed from the display during the first 2 hours the store is open? All right, so you're taking this thing here. There's the rate that they're going out for the first 2 hours, 0 to 2. You go through, if you want to go through and do that, you're looking at a definite integral. Okay, so set that up and use your calculator to evaluate it. Find f prime of 7. Take that function. You want to find the derivative. Now, again, this is your calculator you have, okay? Option 1 is to go through and take the derivative of that and then plug 7 in and evaluate it. Option 2 is put that function into your calculator to use the numerical derivative to go and answer that problem. And the big part on this one, see, they want you to find f prime of 7. The actual derivative on this one is not going to be a big part of it. You got 4 pieces here. It's going to be 9 points each. You're probably looking at 2 points on this one, maybe 3. Number 1 point for actually f prime of 7, 1 point for the units, maybe, and then 1 point for the meaning. So it might be a 3-point problem here. I'm thinking more along the line of a 2. But notice here, you're dealing with f prime of 7 and then the meaning of that in the context of the problem. That's the key part there, not going through and taking the derivative of this one. And keep in mind, if you did, you'd still have a product rule right here, as well as a chain rule with dealing with inside. And last time I checked, probably finding the sign of 7 to the 3rd power over 100, that's probably not going to necessarily be something you're going to want to do either, because of the fact that you're dealing with, that's not something from the unit circle. You wouldn't remember that. That's not an angle that you're familiar with. Next one, part C. Is the number of pounds on the display table increasing or decreasing at time t equals 5? Give reason for your answer. Well, notice here, at time t equals 5, both of these are in play. So this is telling me the rate that they're being added. This is telling me the rate that they're being taken away. Look at those 2 values of what's happening at 5 and make your determination there. And then how many pounds of bananas are on the display table at t equals 8? Okay, so to start out with, you have 3 things to take in mind here. Okay, how many pounds of bananas were removed from the table? How many were added? But also, don't forget right up here that you have 50 pounds of banana on the display table when the store opens. Okay, that 50. This, in terms of this one right here was probably more likely to be a 3-point problem, and 1 point is going to become just from going through and taking into account that 50 pounds. Okay, so that would be it for question 2. Hope that gives you some ideas on where to go. Let's go on to question 3. From this point forward, no calculators. So everything here from this point forward would be without a calculator, and the calculations would need to be done by hand. In question 3 here, the function f is differentiable on the closed interval from -6 to 5 and satisfies the equation that f of -2 is equal to 7. The graph of f prime is what's shown up above. Okay, so keep in mind, again, recognize that you're dealing with the graph of f prime, and we want to make sure to go and and, and just circle that, make sure you see that one and you don't forget it, okay? The first thing you have to do on this is you have to find the values of f of negative 6 and f of 5. Well, again, this is the graph of f prime. We know f of negative 2 is equal to 7. And so what I'm going to want to do on this one, okay, this is a value you know. So you want to set up you're going to want to go through and deal with that integral in terms of the areas. So you want to think about the areas that are happening there. One thing you would want to probably do is calculate the areas in the different regions that you have up to the point that you need to have. So in this case, well, f of 5 is here. So f of negative 2 is there. So we know there we're at 7. We have to calculate this area and that area, do the appropriate calculations to find f of 5. And if I want to find f of negative 6, again, I know, remember that f of negative 2 is 7. I have this area here, calculate that area, do the appropriate calculation, I can find f of negative 6. Part B, on what intervals is f increasing? Justify your answer. Okay, now again, this is where you have to be aware of what this graph represents. This is the graph of the derivative of f. So in order, think about what you have to remember, in order for f to be increasing, think about what must be true about the derivative function and then answer the question based on that. Part C, find the absolute minimum value of f on the closed interval from negative 6 to 5. Justify your answer. Okay, again, this is a closed interval, so the extreme value theorem comes into play, that you do have to go and evaluate the function at the endpoints. Well, you've actually already done that, haven't you? You already know what those are, okay? The other thing you have to deal with is identify the places in terms of if you're trying to find the absolute minimum or absolute maximum. We know that's going to occur at critical values, at the critical values of function f, or it could be at the endpoint. So you're going to, again, keep in mind this is the derivative and think about what it means to have a critical value. Identify your critical values and then evaluate and then determine what the function value is at each one of those. And then you can go and make your determination from that point on. Part D, for each of f double prime of negative 5 and f double prime of 3, find the value or explain why it does not exist. Okay. So f double prime of negative 5, so we have to, again, remember this is f prime, so you want to find f double prime. So you got to think about, okay, at f double prime of negative 5, determine what that is. And the same thing about f double prime of 3. When x is 3, f prime is right there. So work with that and make your determination about what the value is, or if it does not exist, make sure you explain how you know it doesn't exist. Okay. Let's go on to question number 4. All right, in question 4, what we're looking at here, this is a potato problem. I remember this one quite well. And notice this gets into a differential equation. At time t equals 0, boiled potato is taken from a pot on a stove and left to cool in the kitchen. The internal temperature of the potato is 91 degrees Celsius at time t equals 0. Okay, so the temperature there, right away, the first thing I'm looking at that one is I got 91, t equals 0. So on that, I now know I have the point 0, 91. So that's my initial value. That's my initial point. And we also are told that internal temperature of the potato is greater than 27 degrees Celsius for any time t greater than 0. Okay, so we have a lower bound in terms of the temperature. We're not going to go below 27 degrees Celsius. The internal temperature of potato at time t minutes can be modeled by the function h, which satisfies the differential equation. So this is not function h. This is the derivative of h. The derivative of h with respect to t is negative 1/4 h minus 27, where h is measured in degrees Celsius and h of 0 is 91. Okay. So you got a couple different things. Keep in mind, here's your differential equation. Notice we're using the potato temperature, okay, which we know h of 0 is 91, and we know it stays greater than 27. So I know h minus 27 here is always going to be a positive value. Okay, that's something you need to recognize on this one. The first thing they want you to do is write the equation of a tangent line to the graph of h at t equals 0. Use the equation to approximate the internal temperature. Well, you know at t equals 0 that the temperature is 91. So there's our point right over here, 0, 91. You just have to find the slope, which is the value of dh dt. Remember, not t, you're putting in h. Okay, so do that one. And then use that equation to approximate the internal temperature at time t equals 3. The nice thing about something like this one here for them is that there's no error that's going to take place. Okay, you should get the exact same answer on that one. Next thing, use the second derivative. So here's dh dt. You've got to find the second derivative of h to determine whether the answer in part A is an underestimate or overestimate of the internal temperature. Okay, now this is an interesting problem here because really what you've got to go through, think about, we know the second derivative is going to tell you if the function is concave up or concave down. So I want you to think about, for this one right there, you're going to get this particular value here. Then you're going to go here, okay? I want you to think about graphically when a function is concave down, where the tangent line is at, and when a function is concave up, where that tangent line is at. Okay, so you take a look at it. This is a common type of problem here where they're going to ask you to go through and determine whether something is an overestimate or underestimate. And this happens as well with going through, if they ask you to use a trapezoid rule on another problem. If they ask you to use a trapezoid rule, they might ask you to tell if it's an overestimate or underestimate. Okay, in both of this situation and in the trapezoid rule, what you're concerned with is the concavity of the function. So go ahead, take your second derivative, determine what that is. Think about what that second derivative is going to end up being for the values in our domain here, and then you can go from there. Okay, answer that question. For part C on this one, for t less than 0, an alternate model of the internal temperature of the potato is given at time t minutes by this function here. G that satisfies this here, and where g of t is measured in degrees Celsius, and again g of 0 is 91. So our initial value is still going to be, when you put 0 in for t, you're going to get 91. Find the expression for g of t based on the model. What is the internal temperature of the potato at time t equals 3? Okay, so what you're going to have to do, you have to, in this one right here, notice we never asked you to go through and find h of t up here. They want you find the tangent line to approximate, and then this one right here, they're asking you to go through find g. Find an expression for g. So you're going to have to separate the variables and go through the process of finding that equation and then answer the question based on that. Okay, plug t is 3 into your model and see what you come up with. Okay. With that would conclude this one for question number 4. Let's move on to question number 5. In question 5, two particles move along the x-axis. For t going from 0 to 8, the position of the particle at time t is given by x. X of t equals the natural log of t squared minus 2t plus 10, while the velocity of particle q is given by the velocity of q of t is t squared minus 8t plus 15. Particle q is at position x equals 5 at time t equals 0. So what they want us to do here is the first thing they want you to do is they want you to go through for t going from 0 to 8. When is particle p moving to the left? Okay, well, you have, this is your position of particle p. Remember, when you're working with this one, if you want to tell whether or not it's moving left or right, that's when you're going to need to go through and use the derivative. Okay, look at the derivative. The derivative is velocity. That's going to tell you left is in the negative direction, right would be the positive direction. So that would tell you whether or not when you're moving to the left or to the right. For time t equals 0, from time t equals 0 to 8, find all times t during which the particles are traveling in the same direction. So really what they want you to do is determine when are the particles both going, when are the velocities both positive or both negative. Make sure you're checking for both of those. Also be aware that places where the critical values for the velocity of p and the velocity of q may not line up. They may not line up. So it might be that it's not going to necessarily be between two critical values for one function, but it might be where you're looking at critical value of one, between a critical value of one and a critical value of the other. So be very careful with that. Plot those out. It might be good in this case to just think about the intervals where each one is moving, look at where each one is moving to the left and to the right, and then look at the overlaps of those as well. For part C, find the acceleration of particle q at time t equals 0. Is the speed of particle q increasing, decreasing, or neither at time t? Explain your reason. Okay. Acceleration, again, we know acceleration, again, is the derivative of the velocity, so you got that one. But we've talked a number of times, in order for a particle to be, the speed to be increasing or decreasing or neither at a time, there has to be something happening between the velocity, something that's true about the velocity and the acceleration. So look at that, keep that in mind. So on a problem like this one right there, where they're asking you if it's increasing or decreasing, you're going to need to evaluate that velocity function too. And for part D, find the position of the particle Q the first time it changes direction. Okay. So again, what's happening here, we're starting at t equals 0, and we're looking at, okay, what is the position? So we know particle Q starts at 5. But t equals 0, it's starting at 5. So you got to look at that, and then you have to look at, I determine critical values, because that's where this thing is going to be changing direction. And you're going to have to go through and determine, based on the definite integral, what is the value of that. So don't forget, though, that when t is 0, x is 5. Okay? And that should give you your position, if you take that in mind, plus the amount of displacement that you have. Now let's take a look at question number 6. This is the last question on this portion on this exam. What we have here is we're going to have a function f of x is given as cosine of 2x plus e to the sine x. And g is a differentiable function. The table above gives values of g and its derivative g prime at values as selected values of x. So we have this table up here that is g and g prime. Okay. Now h is a function whose graph consisting of 5 line segments shown above. So this is function h. So look at what you got. You have 3 functions. F, where they give you the equation, g, defined as a table, and h, defined as a graph. Okay? You've got to be aware of all of those. Now the first one here, find the slope of the tangent line to the graph of f at x equals pi. All right. So right there, we know we're going to have to take the derivative of this. Okay, and we're going to have to evaluate it at pi. So you're going to be working with that. Again, don't forget chain rule. Okay, cosine of 2x, e raised to the sine x when you're taking your derivative. Next one, let k be the function modeled by k of x as h of f of x. Find k prime of pi. Well, we already found f prime of pi, haven't we? what you're going to need to do on this, you're going to need to go through and take the derivative of this function, okay? Now remember, start out with the chain rule, and don't, as you're working on that particular one, don't get too worked up about the fact that you don't have a function h. Just go through, and you know k prime of x is going to be, by the chain rule, the derivative of h with respect to that inside function f of x times f prime of x. So there's our derivative for k, and now you're going to have to evaluate h or k prime of pi. So just plug pi in, and you're going to get different values here and here, and then you're going to use that to go and tell you, up here to identify, once you know the values for these, then you can go through and use function h to evaluate the derivative of h at whatever f of x is. Okay? Let m be the function defined by m of x equals g of negative 2x times h of x. Find m prime of 2. So again, chain rule, and you're dealing with a product, so don't forget the product rule as well. And for part D, is there a number c on the closed interval from negative 5 to negative 3 for which g prime of c is equal to negative 4? Okay, well, negative 5 to negative 3. From negative 5 to negative 3. This one again is looking at, it's really looking at the mean value theorem again. Okay, you got to look at function g. Remember, by the mean value theorem, we know that if a function is continuous and differentiable, which we are told g is, that g prime of some number c would be equal to g of b minus g of a all over b minus a. So go ahead and take a look at those, see what happens with that, and you should be able to determine whether or not we are going to have a function there. But again, when you're seeing something like this one, you should be thinking mean value theorem in terms of that. Okay, so this right here does conclude some hints that I have for the different problems you have here. Make sure that, hopefully you've gone through, given this your best shot, and seen what you could come up with on your own, and hopefully this can help clear up anything else. We will be discussing, we'll take a look at some of these. We'll talk more specifically. I have more information to give you about especially these last ones, and we will talk about, we'll look at in terms of grading some of these as well. So with that, I hope that you have had a great break, and I will see you on Wednesday.